Breathing. We do it on average 20,000 times in the course of a single day. And mostly, we are completely unaware of it. Breathe in and breathe out. We usually only realize how important functioning respiration is when it is obstructed by a cold, for example. So let's take a closer look at our respiratory tract. The inhaled air first reaches the throat via the nose or mouth. Together with the larynx and the paranasal sinuses, these anatomical spaces constitute what are called the upper airways. The windpipe and the adjoining bronchi belong to the lower airways. The airways as a whole are a functional unit. From the nose via the paranasal sinuses to the bronchi and are lined with a protective mucous membrane. Now for another detailed look, this time at the general structure of this mucous membrane, taking the bronchial mucosa as an example. Like the ears of a field of grain touched by the wind, thousands of millions of cilia perform the same movement over and over. Goblet cells situated between these cilia produce, together with the mucous glands, a thin watery mucus in which these tiny hairs are embedded. Minute dust particles infiltrating the airways stick to this mucus like insects to adhesive tape. But viruses and bacteria too are carried off towards the throat and are reliably removed. A very effective natural mechanism of self-purification known as mucociliary clearance. It is important to understand that this composition of the mucous membrane, and thus the mucociliary clearance, extends over the entire respiratory tract. This ingenious system is easily disrupted, however. Dry air caused by air conditioning and heating, colds, allergies and smoking all affect the mucous membrane of the airways. The result is a slowing down of the ciliary beating action, even as far as to a standstill. Dirt particles, but most importantly pathogens, can no longer be removed effectively. An infection is imminent. The simulation illustrates impressively what happens. Bacteria and viruses that we are subjected to on a daily basis now have an easy run because of the damage to the mucosa and lack of coordination in the beating action of the cilia. The pathogens attach themselves to the mucus and do additional harm to both cells and cilia. And what's more, the germs seem to thrive in this environment, multiply and cause further damage. Initially, this damage often manifests itself in the typical symptoms of a cold. In most cases, the upper airways are affected first. A throbbing head, a blocked nose, a bad cough. The coughing develops through additional irritation of the cough receptors in the pharyngonasal cavity. Without early treatment, the paranasal sinuses will become affected as well. This is due to insufficient ventilation via the nose and leads to the clinical picture of sinusitis. A pressure headache that gets worse if one bends forward is characteristic for this condition. If the inflammation is allowed to spread further, then the damage to the mucous membrane can progress unchecked from the upper to the lower airways, and the illness reaches a new level. The main symptom of developing bronchitis is coughing. Instead of the usual watery secretion, the mucigenous cells of the bronchial mucosa now increasingly produce a much more viscous mucus that further impairs the regular beating action of the cilia. The cilia are virtually stuck fast in this thick mucus. Any ability to carry off infectious germs is inconceivable under these circumstances. Expectorating the mucus now becomes very difficult, but our body has defense mechanisms at its disposal. Attracted by the germs, special white blood corpuscles, leukocytes, migrate into the bronchi and try to capture the intruders. The main purpose of these white blood corpuscles is to devour the invading infectious germs, thereby destroying them. During digestion, aggressive fragments or radicals develop from oxygen molecules. Necessary as these radicals are for the destruction of the germs, they are unfortunately also detrimental to the mucous membrane because of their hyperactivity. Here, as an unwanted quasi-side effect, they cause an inflammation that in the end has to be combated by therapeutic measures. To avoid the spreading of an infection from the upper to the lower airways, the treatment has to start as early as possible. The purely vegetal active ingredient myrtle standardized in GeloMyrtol Forte takes effect comprehensively and directly at the seat of the infection. In capsules resistant to gastric juices, it travels through the stomach intact and reaches the small intestine. Only here is the active ingredient released and resorbed. Then it selectively reaches the upper and lower airways via the blood. Here, myrtle standardized causes watery secretion to begin again in place of the discharge of viscous mucus. The cilia recover and are able to resume coordinated beating action. The mucociliary clearance starts up again. Bacteria and viruses are carried off once more. But myrtle standardized also acts against the damaging radicals. It covers the activated leukocytes with a protective layer and thus reduces the release of radicals. While the destruction of the germs in the leukocytes remains uninfluenced, unwanted damage to cells in the area of the mucosa of the airways is prevented or repaired. Additionally, antimicrobial effects that damage the germs directly have been proven. Thanks to its comprehensive effect, GeloMyrtol Forte has the entire spectrum of sinusitis and bronchitis covered, from the beginning of an infection to its full-blown manifestation. It is best to treat an infection of the airways early, as soon as it starts. Here already, GeloMyrtol not only eases the sensation of illness, but demonstrably contributes to restarting the mechanism of physiological self-purification and to protecting the mucosa of the airways against cell damage. GeloMyrtol Forte acts efficiently and offers noticeable relief.